rectilinear or straight line motion. Now we have a few functions that we need to look at. The first one is displacement, which is often s of t. It's to do with change of position. Sometimes it's called x of t as well, because often the motion is along an x-axis. Displacement is left or right from the starting point. Now this is important. Displacement is related to distance, but direction matters. So if we have a starting point here, O, actually that's not always the starting point. The object may start not at O, but there's certainly a fixed point on the line from which distances are measured. If the object was, say, here, then we would say its displacement was equal to 2. But if it was over here, such that this distance is 3, then we would say x of t is negative 3. In displacement, it is important whether we go left or right from the starting point. So the distance here would be 2, the distance here would be 3, but the displacement here is 2, the displacement here is negative 3. Now, distance, we've just been discussing that, is how far an object travels regardless of the direction in which it travels. Now here's a little thought experiment that I often talk about with classes. So here's me. What I'm going to do, the class are all sitting here, little thought experiment, I'm going to go out to my car, I'm going to drive to the airport, I'm going to fly over to Cape Kennedy, I'm going to persuade NASA to get the next Apollo mission that never flew out, and let's fly it just for me, for the sake of this experiment, and I'm going to go to the moon, which is about 250,000 miles, roughly. Then I'll come back, reverse the journey, but when I get back to the classroom, I'm going to stand here instead, a distance of 1 meter to the right of where I was originally. So distance, I've travelled about 500,000 miles, but when I get back to the classroom and stand here, and the class is still waiting for me obviously, then my displacement will be 1 meter, because that's how far I am from the start point. This difference between displacement and distance is sometimes hard to understand, but hopefully this helps. So let's suppose we had an object that started here and went to here and then reversed direction and came back to here. Then the distance travelled is going to be about 5 meters. However, when it gets to here, the displacement is just 2 meters, because it only compares where it is with the original start point. Now velocity, v of t, that's the rate of change of position. If you think about it, how do you measure your speed when you're going in the car? If you're going faster, you cover more distance in the same time. So velocity is the rate of change of position with respect to time. So it follows that v of t is dx dt. So we get velocity by differentiating displacement. Acceleration, a of t. That's the rate of change of velocity with respect to time. Once again, think about being in the car. If you put your foot down harder, then your acceleration is greater, which means your velocity changes more quickly. So a is equal to dv dt. We get acceleration by differentiating velocity. So, going in this direction, if we have displacement here, velocity here, and acceleration, to go from one to the other, we differentiate. And later on, you might go the other way, and you'll use a process called integration, because that's the reverse of differentiation.